Hi guys, it's Miss Van Dyke again, and welcome to your 1.2 notes. Today we will be studying the order of operations, and we will evaluate expressions. So go ahead and take this 1.2 notes PDF, download it, print it, put your name on it, and let's get started. So our objective is our goal, and by the end of the day, this stands for students will be able to. So you will be able to simplify expressions involving exponents and, hold on, let me zoom. Students will be able to use the order of operations. So let's start out with a little warm-up activity. Say I've got 5 dots and I put them here and here. I'm going to copy those exact same dots and put them over here. Now, if I want to connect the dots, like literally connect the dots, not like put together some ideas, I can connect them theoretically in any order I want. I can start with this one, and then I could go over here, and I could go over here, and then I could go there, and then I can go here. And if I do that, that'll look like this. I go, hold on, yeah. I'll go here, 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 and let's end back there. Oh, look, guys, we made a star. Oh, because you are just shining, brilliant students. But that's because we went 1, 2, 3, 4, 5. Now I can also connect them in another way. If I start here, I could just kind of go around the circle, and spoiler alert, I spoiled it. That's what it ends up being, connecting 1, 2, 3, 4, 5, and back to 1. It's kind of a sad circle, but it's a circle. Or if I probably should have made it a pentagon like this. But that's okay. Either way, say good job. You tried. So it's the same dots, but the order matters. It's like my niece, if I tell her to put her socks and shoes on, I have to specify to put your socks and then your shoes on, because she won't put them on in the right order. So order matters. Put your socks and shoes on, guys. Let's talk about some definitions. All right. So let's talk about a power. A power is an expression with a base and an exponent. And that's probably kind of abstract. So let's look at an example. Here's our first example. We've got 4 to the second power. And this 4, that's our base, because it's kind of the big one. It's at the bottom. Your base here is 4. And then our exponent is this little guy up top. He's kind of extra exponent. You put him outside. That's what exponent means. So our exponent is 2. And we read this as 4 to the power of 2. Whoops. 4 to the power of 2. And if you like your little fancy words, you can be like, oh, isn't that squared? Yes, it is squared, because squared has an extra little shortcut to it. Similarly, your base doesn't have to be a number. Your exponent doesn't have to be a number either. But here we have a base. Our base is a variable. The specific variable is x. And our exponent is still 2. Nice. Way to keep it consistent. Our exponent is 2. So we can read this as x to the power of 2, or x squared is fine as well. Now one of our key ideas here, let's put a star, because it's a key idea, is about simplifying. Simplify an expression is replacing it with a single numerical value. The simplify, you see this little word in here, simplify. You want to make it simple. We like to make things simple here. Okay, so what is the simplified of We do. Simplified form of each expression. Well, when you have an exponent, that means multiplying that many times. So this expression appears the same thing as 4 times 4, or rather 4 twice. And this guy is the same thing as x times x, or rather x twice. There's one x, there's another one, it's x times x. So this guy down here is not 70, not 70. It is 10 with 7 zeros. 1, 2, 3, 4, 5, 6, 7, giving us 10 million. And this guy is just kidding. Yeah, 0.2 times itself 5 times. Just give me a second, I'm gonna copy them over. Which is 0.2. So 1, 2, 3, 4, 5. Nice. Which is the same thing as 0.123332. Crazy, right? Crazy. Notice, this is not 1. Because this does not mean 0.2 times 5. It's 0.2 times itself 5 times. 1, 2, 3, 4, 5. Nailed it. Okay, we're going to move on. So we found up ahead, especially when we're putting our socks and then our shoes on, that order matters. Order is important. If there's anything you remember from today, order matters. But also you want to know what the order is. Hey look, our order of operations is PEMDAS. You might have seen this before. PEMDAS stands for parentheses, I should spell parentheses right, huh? Parentheses, exponents, multiplication and division, and then addition and subtraction. So to help me remember this, you'll notice it's got 4 tiers. This is because you do all the parentheses and then all the exponents, and then you multiply and divide from right to left, and then you add and subtract. And by right to left, I mean left to right. Yikes. From left to right, add and subtract from left to right. Now, PEMDAS is a little bit of a misnomer because this P stands for parentheses. These are parentheses right here, but any grouping symbol is totally fine. And what I mean by a grouping symbol, I mean, yes, parentheses, but also these guys are called braces. They're curly braces, and these guys are called brackets. You don't have to know what they're called. Just know to do the stuff inside them first, and then simplify your power, like x cubed, and then multiply and divide, whoops, and then add and subtract. So keeping your PEMDAS in mind, go ahead and try each of these examples. You should get 32 and 3. If you have a question, be sure to see the extra explanation video that's posted on Schoology, in which I go super in depth. Because if you got this right and you're like, hey, it is 32, nice, then you can go on, you don't have to watch the video. But if you didn't, if you made a silly error or don't understand, you can watch this extra video for extra steps. So that's how to simplify an expression. We're going to follow the order of operations. Rather, an algebraic expression. Shoot, I misspoke again. Okay, and I really don't want to redo this. So this is simplify a numerical expression. Remembering that numerical means numbers. So we have two types of expressions. We have numerical expressions and we have algebraic expressions. You can evaluate an algebraic expression by replacing each variable with a given number. This will give you that expression's value. It'll say, hey, what's it worth? What's this value to you? And it'll give it, you'll result in a number, which is great. So I like to color code when it's time to evaluate expressions. So here we're given two variables. We're given x is 5. So every single time I see an x, I'm going to put a 5 there, here and here. And every single time I see a y, we're going to put a 2 there. I'm going to put a 2 here, a 2 here, and a 2 here. Okay, so I'm going to rewrite these real quick. That's the same thing as 5 squared plus 5 minus 12 divided by 2 squared. And I can rewrite this guy as 5 times 2 squared divided by 5 times 2. Again, this is because I took all of my x's and made them all 5s. And then I took all of my y's and made them all 2s. From there, I'm going to follow the order of operations because now we have a numerical expression. Hey! So we can follow the order of operations to simplify it up. Let's go ahead and take some time. Pause this video, take some time, and simplify it best you can. Okay, did you get 27? Whoop, I don't know what happened there. That was a struggle. Did you get 27? And did you get 10? If not, go ahead and check out. Oh no, it froze. My iPad's not scrolling. That's really weird. Here we go. Go ahead and check out the extra explanation video, either now or when you're done with your notes. Okay. Here's the big one. Ryan got a new job at the bookstore. Nice. He wants to spend a little money on books now. Sorry, excuse me, I have the hiccups. So he wants some spending money and he wants to save some money for a guitar later. So we need to write an expression for the spending money he has left after saving, after depositing 2/5 of his wages in savings. Again, we're saving it for a guitar. So we're going to evaluate, and then after that, we'll evaluate the expression for the weekly wages of $40, $50, $75, and $100. So basically what's happening is Ryan's committing to save 2/5 of what he earns. Now he wants to see how much he'll have to spend based on how much he earns. So if he earns $40 in a week, he'll spend less than if he earned $100 a week. So first, let's come up with an expression for how much spending money he'll have. So he can spend, it says 2/5 of his wages and savings, so he can spend whatever is left. So if we start out with wages, he'll get rid of 2/5 of that by putting it in savings. So he can't spend 2/5 of his wages because this stuff is in the bank. It's not available. So we're going to take it away by minusing it out. So we have whatever his wages is. We should probably put a little note. W is wages. There you go. So whatever his wages are, we minus 2/5 of those wages, and that's how much he can spend. Cool. And now we're going to evaluate the expression if his weekly wages are $40, $50, etc. Now, we could do a lot of work, but I like to organize my work. Now I'm going to organize them by putting them in a table. Now a table is something that has columns and it has rows, and you put lots of information in there. So the first thing we're going to put on our far left column is wages. Remember, wages is represented by a W. And in our problem, we have all of our wages are green. So that's fun. On our wages, we decided we're going to be $40, $50, $75, and $100. Now, what we want to find out is we want to find out how much spending money he has. That's his spending money right there. So at the very, very end, we want to get to what's his spending money. Whoops. Okay, we have our starting part, our wages. We have our ending part, our spending. Now we need to figure out how to get there. If only we had some sort of expression based on wages that will tell us his spending money. Wow. Okay, so we're going to take that very expression, and that's what will go in the middle. I'm actually going to put it off to the side a little bit so that I have space to show my work. Ready? I'll do the first one with you, and then we'll leave the rest as an example, as an exercise. So everywhere we have wages, we're going to replace those wages with 40 because 40 is his wages. So we'll get rid of the W and instead write 40. And here we'll get rid of this W and instead write 40. Now we want to evaluate this expression. We want to simplify it best we can. So let's look at our PEMDAS. We love it. Okay, so parentheses. We have some parentheses, but there's nothing to do inside of them because it's just 40. So we're done. We don't have any exponents. We have multiplication and division. Ooh, from right to left. So we'll start with our 2 divided by 5, which is 0.8. So we're going to leave the rest the same. And by 0.8, I mean 0.4. So we have 40 minus 0.4 times 40. Cool. And then we also have another multiplication right here. 0.4 times 40. Well, that's 16. So again, this came out to, nope, I lied. This came out to 0.4. And this is 16. So we get 40 minus 16. And 40 minus 16 is 24. So that tells us that if Ryan earns $40 in a week, then he can spend $24 on books. Awesome. So go ahead and evaluate this same expression, whether Ryan earns $50, $75, or even $100, and see what you get. Pause the video and then play it when you have your 3 answers. Oh, and by the way, it might help to put a little bar like this so you don't go over the space like I did. Yikes. Okay. And now it's a true table. Okay, now pause the video and try the examples. All right. Did you get 30, 45, and 60? If so, good job. If not, remember to go back and find the extra explanation video for a more in-depth look at this example. That's our lesson on order of operations and evaluating expressions. Go ahead and include the most important thing to remember from this lesson, a question you have or something you wonder about, and invent a question. When you're all set with that and you finish this video, go ahead and work on your homework. And remember to show your work. Show all the steps of your work. Hope you have a wonderful day.